Hi, it's Griffin, and we're going to go over the Driver Station app. First off, what does Driver Station mean exactly? So, throughout my time in FRC, I've heard the word Driver Station mean the laptop. I've heard people call the application the Driver Station. I've heard people call the physical location that the driver and operator and drive coach stand in the Driver Station. But for this course's purposes, Driver Station refers to the app. So this is the Driver Station app. A basic overview of what it does is allow communication. It's the way that controllers communicate to the code load on the robot. The controllers connect to the laptop is Driver Station sends those inputs over to the robot. It's also the way that you can receive information back from your robot, including printouts and errors, which is very important to know. It's also the way you get diagnostic information about your robot, like voltage, how much processing power its onboard computer is taking up, and more. These are often useful for debug. We're going to link the official WPILib documentation to Driver Station, which will go over what we cover in the video and more. You can read that if you want some additional info. Now we're going to open up Driver Station. So, to open up Driver Station, you can search for it in your applications. Run it. Here is the Driver Station. So, the Driver Station has multiple tabs to this side, and in each Driver Station tab, there's a lot of info. So, we're going to cover all of it. First off, this is what we like to call the main tab of the Driver Station. This is the tab that you'll work with the most often. First off is the window button. If you're running it for the first time, it might start in this one that looks like a little curvy arrow. The only difference is this one allows you to move the Driver Station around the screen. Typically, in my experience, the button that looks like a square that pins it to the bottom is more useful because then it allows you to open up any other tabs and keep them in front. For example, if I pull up the slideshow, open Driver Station, it just sits down here, so then you can still read what you have here and interact with it. Next up, we're going to talk about selecting modes. So the Driver Station allows you to select essentially how your robot will run. There's teleoperated, autonomous, practice, and test. Teleoperated mode is the main mode of a robot. It's the one where you have humans with controllers telling the robot what to do. This is the mode that's run for the majority of an FRC match, and we usually call it teleop for short. Next, there's the autonomous mode. The autonomous mode is the mode where the robot is controlled exclusively by pre-written code. We call this mode auton for short. An important thing to note for safety, be very careful with this. If you run your robot in autonomous mode by mistake, it will instantly start executing whatever commands you have saved for it to do during the autonomous period. This is a safety hazard if you didn't expect to run in autonomous mode and you expected to run it in teleop by mistake. So you should be very careful to select the right mode. Next up is practice mode. Practice mode is a mode where the robot completes a timed auton period, followed by a delay, then a teleop period. The reason it's called practice is because this is supposed to simulate the real flow of an FRC match, because it goes autonomous, delay, teleop. The specific timings for this can be edited in another tab. For example, how long you want the delay to be, how long you want to let the robot run it autonomous. Typically, if you're practicing, you want to match these times to what it would be in an actual match. Finally, there's test mode. Test mode can be useful to a programmer because you can allow certain functionalities to only be run while in test mode. There are parts of the code that are only run. You can identify whether you're in test mode with an if statement. We will not be using test mode throughout this course, but just know that it is a capability. Next up for the Driver Station's main page are the enable and disable buttons. This is essentially the running status of the robot. In disabled mode, no motors are allowed to run on the robot, no matter what, even if your code is telling them to. In disabled, they will not run. This is a safety feature. Do note, though, that the robot can still be on in disabled mode. There will still be voltage running through the robot, but the motors will not be able to move. Additionally, even if you're in disabled mode, if your robot is turned on, there will still be code running. This can be useful for getting diagnostic info without the risk of motors running. Another way to identify that your robot is in disabled mode is by looking at its RSL light. This is an RSL light. It is required by FRC when you're in competition to have an RSL light on your robot. If the light is solid orange, meaning that it is not blinking at all, it is just holding an orange color, that means that your robot is on but disabled. Next, the counterpart to disabled is, well, enabled. In enabled mode, motors are allowed to run. You should make sure to be careful here, though, because this is when the robot is at its most dangerous. I'm going to list some good practices that you should probably implement on your team whenever you enable a robot. It's important that you keep distance before enabling. There shouldn't be anybody with hands in the robot. There shouldn't be anybody within the path that you expect it, or even that you think it plausibly could move. This ensures that you won't have any accidents because FRC robots are dangerous. Big, heavy metal that can move fast that could seriously hurt somebody. You should also be sure that the people around are aware that you're about to enable the robot. You should shout enabling before clicking the enable button. Additionally, you should have somebody ready to disable the robot. Now, the enable button can only be activated by hovering your mouse over it and then left clicking. On the other hand, the disable button can be activated simply by pressing the enter key. You could have your code up, I could have this Google slideshow up, and I could press that enter key on my keyboard, and the robot would disable. It doesn't matter. You should have somebody with their hand close to the keyboard, ready to click the enter button if somebody calls to disable. Another thing you might run into is pressing the spacebar emergency stops the robot. This is like a disable, except you cannot re-enable the robot until the robot is shut off, driver station is closed, and the robot is turned back on and driver station is reopened. One final safety comment I have is that you should disable the robot when you're done with whatever testing you're doing. In the heat of the moment, while your team's trying to figure out an issue, it can be easy to forget that the robot's still on. As much of a stray brush of a hand on a joystick could send it flying in an unknown direction, which could really hurt somebody. You should make sure to disable as soon as you're done. Next, another thing to be careful of, especially for safety, is Team Station. In this tab, the color is associated with what alliance you're on, while the number is where your drivers would be stationed on the field. Typically, the number doesn't really matter in how the robot runs, but the alliance color can a lot. Sometimes you might have an autonomous routine that you want to run differently depending on what side of the field it's on. And forgetting to change the color can cause the robot to move in a direction that you didn't expect if you have the colors wrong. This can be a major safety concern because you never want the robot moving in an unexpected manner. Make sure to check this before enabling your robot. Next on the main tab is this robot info section right here. It has your team number, which you edit inside driver station. I'll show you where to do that later. Additionally, you have this, which if you had a robot connected would show the battery voltage through some bars that represent the voltage draw. Additionally, where these lines are would show the active voltage of the robot live. This can often be useful when trying to debug electrical issues. This communications box indicates to you whether the laptop is able to connect to the robot. The laptop can connect to the robot over either Wi-Fi, Ethernet, or USB A to B. This little box will turn green when you have successful connection. The robot code box similarly describes whether the robot has code that is successfully running. If there's a robot project that is loaded on the robot's central computer, the RoboRio, and the code has not crashed in any way, this box will turn green. Finally, there's the joystick box. The joysticks box will turn green if any joysticks are connected to your computer. Next is this big wide box right here. This is where the logs go. This is where any console prints would go. This is where errors show up. This is very useful because it can help you diagnose issues. And additionally, your robot automatically keeps a log of all the history of what's happened. If you click on the settings cog right here, then click view log file, it'll come up with all of the times that you've run your robot. If you click on any of them, you could see date events versus times. If this was on a real robot, you'd see battery voltage changing. You'd see all of these categories to the side, RoboRio CPU usage. And if you click on this upper tab event list, it'll show you that log of what happened in the console. This can be critical post-match if you had an issue to figure out what went wrong. Okay, we're going to move on to the next tab now. This is the Diagnostics tab. This has a lot of information about your communication to the robot. It shows stuff like whether the Ethernet's connected, what the robot's IP address is, what type of Ethernet's connected, whether there's a firewall on. This can be useful to check if you're having issues with your communications to the robot. It also has these two handy buttons right here, Reboot RoboRio and Restart Robot Code. Rebooting the RoboRio completely restarts the onboard computer of the robot. Note that this can take a while, like 30 seconds plus. You should probably only reboot the RoboRio as a last resort because it can be a lot of time, especially when you're trying to debug quickly. Restarting robot code, on the other hand, is very useful. All it does is reruns the code from the beginning, which doesn't take very long. That means that if you need to reinitialize anything, this is the way to go. Moving along to the Settings tab, this is where you enter your team number. Type it in this box. It also has those practice timings I was talking about before, the autonomous, the delay, the teleoperated. This drop-down menu right here gives you the type of dashboard that you'll be using. That's like this big box over here with gyro and these features. This is the default dashboard. We won't be using in this course. We like to use shuffleboard. So if you select shuffleboard will then boot with your robot. Moving along to the controller connections tab, this shows a list of all the controllers that are or have been connected. If you click rescan, it refreshes this list. If you connect a controller like I just did, then click the rescan button, it'll show up in green. It shows info about what the controller's buttons are doing, like if I start pressing buttons, it pops up. This is useful in your code for identifying what ID each button is. We'll talk more about that later. One important thing to know is this USB order. You can drag the controller around however you want. By default, the controllers will appear in this order depending on what order they're plugged into the computer. But if you set it up in a specific slot and then double click, you'll see a little underline, and that'll mean that no matter if you go and you unplug it and then you replug it in, it will always show up in that slot. If you want to remove an old controller from this list, triple clicking gets rid of it. The final tab is the CAN information. CAN is like the wiring that allows communication within the robot. We will not delve into this in this course, but it can be useful to investigate if you're having issues with CAN, and you can read further about this in the WPI Lib documentation. You're going to be using the driver station a lot throughout this course and throughout anything that you do in FRC programming, so it's important to know your way around it. Now you have a good overview of how to use the driver station.